Hello again. We made it, number 10. Wow. Very happy about this. Alright, let's go. So, um, oh my gosh. I haven't really done too much since the last update. I I made a build. That was good. I made a build, and it didn't work. Uh, so it turns out that there's still some errors that are happening in the build that aren't happening in my editor. I talked in the last episode, the last log, I guess, that I've been making different tests to actually test whether or not things are desyncing inside of the editor, and they're all passing. So the two servers can like boot up, connect to each other, and run code, and everything looks fine. But there's different behavior that's happening inside of the clients. So that's a big problem because it takes ages to make builds, right? At least these IL2CPP builds, I need to test with like regular super duper uncompressed builds, which I'll do today. But I'd like to actually like also test with these IL2CPP builds, which are very compressed. This is when the code gets crushed down a bunch, and make sure that those are functional because there are always special errors inside of that compared to the regular code. So I've been coming up with a pretty cool way to do these tests. Because right now, to actually test whether or not things are working, I have to make a build, I have to boot the build, I have to boot the editor, I have to make a server on either of those, I have to then go to the other application and connect to the main, the person who's hosting, or the client that's hosting, and then play for a little bit, look at the logs, do something. Right? That's not good enough. That is not the way that this should be working. So I'm working on making unit tests that can run between two, like that. So the Unity editor can effectively like run tests on two separate applications, right? Right now it's just going to be itself and a build, but this is pretty neat. So I'm gonna show you what I've been working on. So, first things first is I've automated tests for every single one of my server calls. So that's really cool. So, this I again, if you're programming in Unity or like if you're programming in anything, I really recommend trying to find a way to do unit tests. Right? It's very difficult to set up doing unit tests on a game, especially a multiplayer game, like particularly a multiplayer game. But if you can do it, it does save you time, right? I've spent probably, I think I spent like maybe 4 days in total of actual dev work, exclusively working on trying to set up my unit tests to be between two different game versions, right? But now that I've done that, I've probably saved that time already, right? And it's only been like 5 months, so that's fantastic. Um, so if we have a look at these, my RPCs, right? I talked in the last episode about how I'm generating a bunch of code. So if I go to the lookup table, you can see that I've got all my RPCs already here. So in my tests, I can actually use a value source test. So this is using NUnit. There's a lot of documentation about this on Unity. I recommend it. And these are IEnumerator tests, so I can actually yield and have things take time, which is necessary for these server calls and stuff. And what I do, right, is I create a random source. I run the RPC test on every single type. So this value source points to this static thing, and Unity, when it compiles, it actually generates a tests for every single combination of value sources, right? And so this is just going to run on every single type. So that's all this is doing. And then it runs a unique test on each of them. I'm currently just skipping a couple of these. These ones throw errors, and Unity tests will considered a failure if there are any log errors. also keep that in mind. Get rid of your errors and get rid of your warnings. Do that. Do that today. Fix like 3 of them. All right. Just get rid of some logs. Do it for me. So, we create the RPC. I set the data and then I test it. So there's me setting the data to 0. So this just tests the RPC if no data was inputted, and then I also do 4 tests with completely random data. I need to test this with specific data to make sure that, like, oh, okay, you're trying to run this RPC that targets a network ID, and that network ID is not really an object that you should be calling this method on. I got to make sure that I generate, like, that I fill out this RPC with some, like, proper test values. So I'm not doing that just now. And when I do this test, this is running the full desync test. So I have, test action A, test action B. I mentioned this in the last video, but there's the 3 cases where it's just like single player, where it's multiplayer, where you run both of those and then the client joins, and then there's the one where you run one of them, client joins, run the second one, and then we test for destrings on each of those. So this is going really well. What's new? And this is really, really cool, and I really hope somebody appreciates this, because I'm very proud of this, is we have the build tests. So my plan, right, to test for these builds is I've got a special session. So session, editor, and build. This is similar to what I had in the RPC test, where that was session 2-player. These are both running inside of the Unity editor, right? It boots up a world for the server, boots up a world for the client, connects them together, and closes them. And it can do this multiple times inside of a test really quickly, which is pretty handy. But this test instead is going to it's going to do the same thing, where it can, like, boot up multiple instances of those things. But one of the pair of instances is going to be in the editor, and the other one's going to be in the build. So if we have a look at how this works, is this session object has a special thing called an editor to build pipeline. So this is something that I made. And how it works is, for applications to be able to, like, send messages to each other on the same computer, Microsoft, or C# added this full pipeline, named pipe client stream and named pipe server stream. So the server is the host and the client connects to that. But then once they're connected, you can actually send messages in and out of both of them, right? I still haven't tested this, so I don't know if this is 100% working yet. But don't copy this code. Don't do that. Ask me for the code when I'm done. So how this works is that I wait for the stream to, I guess, be connected. So when, like, a player is actually in, and I wait for the editor. Okay, let me restart. All right, what happens? So the build boots. It creates one of these 2 things. It creates, like, the server, right? And it just openly listens. And it passively does that. It's got a coroutine that's just running somewhere, and it's just waiting, right? The editor will boot, and then when it wants to, it connects to any of the it tries to find a stream with this pipe name, right? So it'll try to connect to this. So yeah, connect async, right? Pipe name. So they're both just kind of, like, listening to this specific string, effectively. Then when the editor finishes connecting, right, it swaps into this running coroutine, where it waits for it repeatedly, like, waits for the build to send it messages, and the build does the same thing, where it's waiting for the editor to send it messages. And all of the messages are in this format. So they're a JSON object for IUnit application message. So this is a little interface that I made. and all it does is it executes on that side of the pipe, right? So there's the editor pipe, and then there's the build pipe. Both of these inherit from this thing that I made as well, Unity Application Access, and this is kind of just like an instance. This is just a way to kind of access the it's just like a wrapper for accessing Unity, right? And we can like look at some of the example messages that I'll be sending, right? So we'll look at a very simple one. Current player index message. So what I can do is I can actually just, let's find an implementation of this. Sorry. Okay, we're gonna look at the start server request. So I can send this object, right? It's got a bunch of values. And when it executes, so if my editor sends this to the build, when the build gets it, it's going to start creating a server and hosting it, right? It can do some extra stuff, so I've got it capable of like simulating up to a certain step, so stage offset and the step offset, and then it's able to send a response. So this is actually what is it? Start as server request response. This is like a little internal thing, and it can send back to the editor the network endpoint that it's hosting on, right? And it can also send back to the editor what its player index is. So that's pretty cool. And start as client request, it can do the same thing. So when the editor gets that message back that, hey, the server is hosted, right? Well, it's received the endpoint at some point, so it can start, so it can actually start joining, right? It can go like, okay, let's create a client, let's connect to that endpoint, and then we'll send some responses back to the build as well. So we'll let the build know what our player index is. We'll let the build know what the step that we ended up starting on is. All right, really cool stuff. And hopefully I can use all of this stuff to actually test with the build. All right. So the next few steps that I have to do is I need to make the Unity editor launch the application if it's not running, right? I might not need to do that. I could just launch the application. Probably make it like launch the application in like a lightweight mode, right? So not showing any visuals or anything like that. So it's just like the core scene, which is where I do like most of my tests on anyway. And then actually run the tests. And I've got this set up so that I can do the same sort of desync tests as well. So test action A, test action B. So like after joining, right? Another really cool thing is that the way that I've set this up, right, is that I can really easily, any action that I want an application to do, I just make it one of these requests, right? I make it one of these iUnity application messages, and I just send it. And I can execute the same methods on the editor as I use in the build, which ends up just like making the code really easy, right? So we can see that here, where I have set up editor as server, and I have this little method here, execute server, start a server request, and then also set up build as server, execute server, this. And what this message is doing is I just, inside of this session, I just say like, oh, is editor host? Then message, execute on my local pipeline. And that, because my side of the pipeline, inside of the editor, is going to be like, we're able to receive messages from the build. So I can kind of pretend that I received that message to start a server from the build, so I start the server. Or if I want, to execute on their end, right? So if they are allegedly the server, then I can just send them the message. And it's vice versa down here. right? So execute client. I can, I mean, it's like I can also kind of just do something like this. So it's execute build would just be like would be this, and execute editor would just be this, right? That's this is much much easier explanation for this, right? So I can execute any message on the build, and I can execute any message on the editor. And this is fantastic because it also means that I can swap roles instantly, right? So all of my tests can, uh, it's just great. It's just very nice. Yeah, and yeah. So writing this was pretty simple, right? Um, for example, if I want to actually like advance the step that both the editor and the build are doing, right? So like actually tick something forwards. Then, well, I set up their inputs for the frame, and then I advance is editor host. Oh, okay. I just do this, execute server. Right? So because when the server, right, advances, then it's going to tell the client to also it's going to tell the other side to also advance, right, automatically. So game advanced step. When step has been advanced, then respond and say like, yeah, we advanced the step. And also we can when we receive the response that the server advanced the step, then well, our side can also advance the step, right? So app.game launch singleton dot client dot game dot advanced step. There we go. Glad I didn't miss that. Yeah, I think this is really, really neat. This might be very simple to some people out there, but I'm very happy with this implementation. Maybe I should have looked something up and seen if this sort of a tool already existed, but um, this works like insane. If this works, this is going to work insanely well for me. Yeah, so I'm very excited about this. And if this does work 100% correctly, then that means I'll be able to play the game, right? Because this is going to make testing for these bugs so much easier because I'll just click a button, right? I can even leave the build just kind of running, right, passively, and I can just click a button and it'll just like run a test on both of them instantly. It's I'm yeah, I really expect this to save me a shitload of time. So very happy with this. Oh, another cool thing is like I could make my automated build pipeline just kind of like run this after completing, right? Like just run the tests. So it just tests the build. Oh my gosh. An actual pipeline. It's like I'm working at a real company or something. Really neat. But that's all. Yeah. So pray again. Once again, pray for me. Getting a build. That's the plan. All right. Bye bye.